In this video, we're going to go over something I saw on 60 Cycle Hum just a bit ago. Check this out.
I'm hoping that the new one still sounds good enough that I can recommend it. I'd hate for, these pedals to be out there, people buying them, and they're just getting duds that are, no good, not fun to play with. That would break my heart. It honestly would. Especially since I'm so in love with this pedal. It would be a bummer if you couldn't get it sounding that way again, I talked to Josh Scott about it a little bit in the Affordaboard video that he sat in on, and he was like, there's probably a component variance going on.
So let's see if that's what's in fact going on, if this is an issue of component variance or not. So the problem here is he has this older version of the Cuvave Fuzz, which provides a very Velcro gated sound. And these newer ones that you can find on Amazon now, they don't seem to have this gating feature anymore. It's more just like a standard fuzz. Well, let's take a look. So here we have the stock Cuvave Fuzz, straight from Amazon. Just plugged it in here. We got 9-volt power coming in. All the knobs are set to max. So let's get a sample of what it sounds like. Well, let's do clean real quick. And let's turn on the pedal. That's a lot of noise floor. Sounds like a fuzz, but where's the gating? Why is it not gating? That's what this pedal is supposed to be able to do, is that Velcro gating sound. So let's take a look at this pedal over here. Firstly, noise floor. Hardly any. So this pedal is obviously gating like crazy. It's got that Velcro sound. However, now it sounds exactly like this guy. However, noise floor, noise floor. There's still a little bit there, but not nearly as much. And this guy's got a bit of this is a soft touch switch. So, how did I make the sound that this has over here, and then fix the sound that this guy was supposed to have, the gating sound, and brought that over to here? Well, we're going to find out. We're going to tear open this Cuvave Fuzz, and we're going to make it gate. Okay. So I've already kind of started taking this apart already, but it's pretty simple. You will have to remove some of the rubber here to get to the 4 corner screws. Once you take that off, you will need to take the nut off of the input and output jacks, as well as you will need to take the gain knob right here off of the gain pot and the nut for the true bypass switch. So once you do that, that should pull the top board out here. Or we call it the bottom board, depending on perspective. And then here we'll have a remaining board that's held down by 2 corner Phillips screws, which I've already taken out. And then once you have those removed, the effect board should pop right out. So here we have 2 boards. This is our base board, which contains our power supply and our basic input and output, our jacks and power and such. So we have our barrel jack power coming in here. We also have a USB port right here that's only for power, that goes into a switch mode power supply that boosts the 5 volts up to a hair over 9 volts, where these two will come up together with these 2 Schottky diodes, and then it'll feed a linear regulator, which is right here, which will then output power to the actual effect board at around 8.5 volts. So now we have our board here, which is our actual effect board. So we have two basically 3904 style silicon transistors. This is the surface mount version, the SOT23, and that's pretty much in a configuration very similar to that of a fuzz face, except for it has a tone stack on it. Now, as of the gating, you can kind of see here where we're going to start looking at it, and that is this area here where we have some unpopulated stuff. This is kind of common with a lot of industrial manufacturing, where you have PCBs that are laid out where if you populate it one way, it becomes one thing. If you populate it another, it becomes another. This board was obviously intended to be populated multiple different ways. So there was supposed to be a switch here, and R9 seems to no longer be there as well. Now, one of the other kind of kick me signs we see here is we have a resistor that's actually being shunted. They have a 0 ohm resistor here for the value of R7. And so that's going to be where our journey goes to next. So let's take a look at some schematics here. So before we get into the gating of the pedal, I just wanted to go over the schematic so that we have an understanding of what's going on here. So here's the power supply layout that you found on the baseboard. So here's our barrel jack coming in, and here's our USB port coming in. The data lines on the USB are basically severed. They're not going to anything, so it's just ground and 5 volts coming in. That goes through this switch mode power supply, which is a switching regulator that boosts our 5 volts up to 9.58 volts. So it goes in here, leaves at 9.58 volts, goes through this Schottky diode here, and then goes into our main voltage setup. Or if we had barrel jack power, barrel jack comes in, goes through the little Schottky diode, which will be a tad bit of a voltage drop there, providing our 9 volt supply. Either way, this will then go into our linear regulator here, which is not a fixed output linear regulator, but a variable output. You use a voltage divider to set what you want it to be set to, and it'll take whatever voltage is coming in here, and it's configured to spit out an 8.4 volt output going through this ferrite bead and a bunch of these capacitors here to filter. So basically, power comes in either way and then leaves going into the effect board at 8.4 volts. There we go with that. Now let's actually take a look at the effect pedal schematic. So here we have the actual effect schematic, and this is where we're going to get into how do we fix the gating. Now, when I trace this, the silk screen on there isn't quite clear on some of these values, even after I desoldered them completely off the board. So you'll notice that I have some like question marks where it's just like, well, I don't know what they're going to call it, but whatever. So the culprit to this board that we're having our gating issues is, like I said, R7. So if you look at this and you ignore the tone stack for a moment and just look at this as if it was a fuzz face. On a typical regular fuzz face, you have your transistor here, that's your input transistor, and then you have your output transistor. And between the two, you had usually a single feedback resistor, usually around 100K, that goes between the input and the emitter of that second transistor. So what we need to change to make it gate is we need to increase the resistance in here. So basically, or effectively, gate resistance for the gating effect in a fuzz face pedal is directly controlled by this resistance value here. And because these are all in series, it sums up. So what we're going to do is we're going to remove R7, and then we're going to put a trim pot in there as a variable resistor so that we can set it up to whatever we like it to be. All right, so we're going to remove R7 first because we need that guy out of there. So I'm going to just hit this with a little bit of solder on both sides. You can do this one of a couple of ways. Because this is such a small resistor, you can actually probably blob both sides together and then just let it heat up. And then you can kind of knock it off with some tweezers. And well, I think that's kind of what we'll try to do here. There we go. And that is a tiny, 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 tiny resistor. Can't tell if that's 0805 or if that is, now that's got to be 0603. Let's see if I can get this to focus on that. No. There it goes. Yeah. So that was that 0 ohm resistor. It is now Kaputsky. So now we have to put in a trim pot or something else to act as our new R7. Okay, so now that we have that resistor gone, now we're going to take this trim pot right here. I've clipped one of the legs off. So as you can see here, it's kind of got that little triangle configuration. I clipped off the one on the side here, leaving the one in the center and one more on the side available. That way I can just use this guy as a variable resistor. And this is a mega ohm pot, so this will be a variable mega ohm resistor. So the idea is going to be, I want to make sure that this goes into these two bottom holes right here. So however I can solder that in, that will work as our mod. So there we have our mod. We have our 1 mega ohm trim pot set up here. It's not my prettiest solder job, that's for sure, but it will do the business. We're not shorting anything out. And we got enough room that when we plug everything together, we don't have any issues, and it does actually fit in the enclosure. So before we go do that, we want to make sure that we set the trim pot to a good value. So we're going to need a small Phillips screwdriver to adjust the trim pot, and we're actually going to try driving this guy outside of its enclosure so we can see what happens. All right, let's check it out. All right, so here's the moment of truth. I just left the trim pot where it was, and we'll see if that's a good value or not. So, clean tone on. All the knobs are at max still. That's a good sign. I also don't hear the noise floor issue. Now, we'll get to that in a moment, but well, the gating is definitely working. And the noise floor, as I said too, is gone. Now, the reason that is because we've increased the resistance on that feedback network between those two transistors. In doing so, our maximum volume also drops. So, any extra hum that would have came from, say, the regulators down there, that will be reduced. So now we have a better noise floor, and we have the gating effect that we were supposed to get when we bought this thing. So hopefully that helps. So I think this pretty much sums this up. It can be fixed. It's not like, as Josh Scott said in the beginning of this video, a tolerance issue on a component so much as it was a flat out totally different value of a component value. In this case, R7 should not be a 0 ohm resistor. If you want it to gate, it needs to be a much larger resistor, somewhere around the realms of 470K or above. What I'm guessing happened was, originally when Cuvave released this thing, someone thought it was a good idea to put a high value resistor there, and it went out as a gated fuzz. Then a lot of people probably emailed Cuvave and said, hey, this fuzz kind of sucks, because the sound of a gated fuzz, it's an acquired taste. I mean, I like it. Obviously, Ryan over there at 60 Cycle Hum really thinks it's cool, but the bulk of people are going to be like, that's not for me, I'll pass. So, because Cuvave is a Chinese pedal company, they probably wanted to appeal to that mass, so they changed the value from a high value resistor to 0 ohms, bringing it back into a silicon fuzz phase territory. And I actually should clarify that a little bit better, because upon actually ripping off the components and tracing this guy out and making a schematic, I discovered this is not exactly a clone of a fuzz face. It's actually a clone of a ZVEX woolly mammoth. However, on a woolly mammoth, you'll note that there are 4 knobs on it, and this guy only has 3. That 4th knob on the woolly mammoth is called pinch, and actually, that is R7 on the Cuvave Fuzz. So, the folks at Cuvave just took the knob that was on the woolly mammoth and hard set it to a valued resistor and said, that's what you guys are going to get. Too bad. So there you have it. So I hope you guys like these kind of videos here where we break down into these pedals and see how we can make them sound the way we wish for them to sound. It's not one of our own pedals, obviously, but it's still a good fundamental knowledge to go, hey, if I change this on this style of a pedal, it'll make it sound the way I want it to. So now you know if you were to take any one of our fuzz face type circuits and change the feedback resistor, you can get it to gate or not gate based off of the values that you choose. Anyways, that's it for this video. If you like these kind of videos, press that like button, and if you haven't subscribed, please subscribe. If you want to help us out, check out our website, which is www.diyguitarpedals.com.au, and check out our PCBs, kits, and components. That would really help us out. You might have noticed at the beginning of this video, too, that we had a version of this guy called the Cuvave Fuzz, which is an all-through-hole version with the trim pot readily available. We don't have this as an official offering, but if you guys are interested, please let us know in the comments below, and we'll see if we can make that happen. Anyways, that's it for now. Cheers.